Hello students, Dr. Bhavani Regmi here. Today we are going to continue our math problem on chapter 5. We are going to look into how do we use the moles concept in a full equation. Okay, so let me go ahead and start where we were last time. So we completed converting the grams into number of atoms or molecules, from grams into moles, from moles into grams. We practiced on such problems last time. Today we are going to look into how can we use the concept of moles in a equation. So let's start from there. So as we know, a balanced chemical equation has the coefficient in them, right? It has reactants on the left hand side and products on the right hand side of an arrow. Now I can read this chemical equation as 3 molecules of hydrogen combined with 1 molecule of nitrogen to form 2 molecules of ammonia. The same equation I can read as 3 moles of hydrogen combines or reacts with 1 mole of nitrogen to give 2 moles of ammonia. It means that the coefficient in a chemical equation gives us the mole ratio, and these mole ratios can be used as a conversion factor. Okay, so here I can say 3 moles of hydrogen is equivalent to 1 mole of nitrogen, or I can say 3 moles of hydrogen is equivalent to 2 moles of ammonia. So depending on from which moles to reactant or product where we have to link the two different species, we use the corresponding conversion factor. Okay, let's say if I need to show the relation between hydrogen and nitrogen, I choose 3 moles of hydrogen by 1 mole of nitrogen, or 1 mole of nitrogen by 3 mole of hydrogen conversion factor. Right? If I need to relate the nitrogen with ammonia, I can go with 1 mole of nitrogen over 2 moles of ammonia, or 2 moles of ammonia by 1 mole of nitrogen, right? Depending on which moles do I need on the numerator, I have to choose the conversion factor similarly. So let's see in our next slide how to use that information. So with the same equation, 3 moles of hydrogen combined with 1 mole of nitrogen to form 2 moles of ammonia. What kind of question do we get? Let's see here. So I have here 5 moles of nitrogen, right? If 5 moles of nitrogen react with plenty of hydrogen, how many moles of ammonia will be formed? Okay, so we have to start from 5 moles of nitrogen and we have to get how many moles of ammonia. It means that we have to use the correlation between them. What is the mole ratio between them to find the answer? So let's try this question starting from what we have. We have 5 moles of nitrogen, right? And now I use that as a dimension analysis. I have the mole ratio that 1 mole of nitrogen is equal to 2 moles of ammonia. From the balanced equation, I can write that. Okay, so 1 mole of nitrogen is equivalent to 2 moles of ammonia. Right, so I bring this mole ratio from the balanced equation. So with that equation, now I have moles of nitrogen and moles of nitrogen cancel out. So 5 times 2 I have altogether 10 moles of ammonia formed. Okay, so I make 10 moles of ammonia from starting with 5 moles of nitrogen. That's how we work on such problem. Relating from 1 moles, right here we are given the moles of nitrogen and we got the moles of product, right? When moles of reactant is given, how can we find the moles of product? We have to use the mole ratio. Is that clear? Now, let's try another similar question. Now, this time, if 6.8 moles of hydrogen react with excess nitrogen, how many moles of ammonia will be formed? So now, let me go and get another pen color. Okay, so I have 6.8 moles of hydrogen. This time, hydrogen is the one that is given, right? So up here, hydrogen is the one that is given. And now the question is asking for how many moles of ammonia. So I need to relate the hydrogen with ammonia this time. Right, so I start with how many moles of hydrogen is given? 6.8 moles, right? And then I have to get the moles of ammonia, so I will write the moles of ammonia on the top, right? In the conversion factor, I told you 2 conversion factor can be made. Which one do you plug in depends on what is given and what do you need to solve, right? What do you need to find out? Here, hydrogen is given, so you need to place the moles of hydrogen on the bottom. What is the relation? 3 moles of hydrogen will be equivalent to 2 moles of ammonia. This 2:3 ratio we got from the above equation, right? So now moles of hydrogen and moles of hydrogen, I cancel that out. I have in the problem 6.8 times 2 divided by 3. You get the answer. It should be, the calculator might give you 4.533333 blah blah, right? How can we report this answer is our starting number is 2 sig fig. Okay, so now it means our final answer we should be reporting in 2 sig fig. Okay, so 4.5 moles of ammonia will be the answer here. Okay, similarly on above question we have 5 moles, so just 1 sig fig, right? We have here 1 sig fig, so I write 10 moles, which is actually 1 sig fig, so we are good there. So this is how we figure out when reactants moles are given and products moles are asked. Okay, sometimes we might get a question where we are given the moles of product and we need to find out what is the mole of reactant needed. Okay, so let's try this question. This question has given us, if I need to make 100 moles of ammonia, how much of each reactant will be needed, right? So here this time, the ammonia is given. You need to find how many moles of nitrogen will be needed, how many moles of hydrogen will be needed. So we have to go on reverse way, right? It means let's start with moles of ammonia. So 100 moles of ammonia, right? Let's find nitrogen first. So I would like to place nitrogen on the top. The ratio is, can you see? It's 2:1. So 1 mole of nitrogen is equivalent to 2 moles of ammonia. Okay, make sure that ammonia is on the bottom. Otherwise, you cannot cancel, right? If you flip this 2, it will be a wrong one. So now we have moles of ammonia and moles of ammonia cancel out. We are ending with moles of nitrogen, right? and 100 times 1 divided by 2 is 50. So I can write that. So 50 moles of nitrogen. Similarly, to calculate the moles of hydrogen, you start with 100 moles of ammonia. Now you can do it quickly because you have understood the what is required. So 2 moles of ammonia, right, is equivalent to 3 moles of hydrogen. I encourage you to write like all moles of what is the compound, hydrogen or ammonia, right? Like a student make a habit of writing just the number and they do not write the words behind them, and sometimes it confuses them, okay? So 2 moles of ammonia over here. So 100 times 3 is 300, divided by 2 is 150. 150 mole of hydrogen that we need to make 100 moles of ammonia. Okay, that was much exciting. Now let's look on similar other question where the moles are not given but the grams are given. Okay, so we have to utilize something we learned in earlier lesson. We have to convert, okay, grams into moles if we need, or convert from moles into grams depending on what is asked in the question. So this is the question, how to convert grams of reactant to grams of product. Okay, so if you look on here, we have grams of reactant, that is the starting material given, and then you have to find out how many grams of product will it make. So let's look with this with an example. Ethanol, okay, the alcohol that we find in beer, C2H6O, its formula is given, its molar mass is given. Okay, ethanol is synthesized by reacting this starting material, which is ethylene. It is C2H4. Its molar mass is given. If the molar mass is not given in question, we can use the periodic table, we can find out the atomic weights of each of the element and then use the subscript to multiply them and add all the atomic weights, right, to get the molecular weight. We can do that if the question does not give us. Now, by reacting ethylene with water. Now, equation is given here, okay? In all such question, equation is very important. And the equation should also be a balanced one, because only if the equation is balanced, we do have a correct mole ratios between the reactants as well as products, right? So it has to be balanced. And luckily, this equation is already balanced here. Let's read the question. How many grams of ethanol are formed from 14 grams of ethylene? So starting material, ethylene, it is 14 gram, that is given, and the final product, its mass, its grams, is asked in the question. Okay, so first of all, let's make a plan how to work on this problem and then we will set up. So we are given the grams of reactant, right? We can convert that grams into moles, right? And from the moles of our reactant, we can get the moles of our product. We just learned how to do that in earlier slide. And once we have the moles of product, we can get the grams of our product. Okay, we are using several conversion factor here. Remember, whenever you have to go from moles of one thing to moles of other thing, you have to use the balanced equation ratio. Okay, whenever you have to go from grams to moles or moles to gram, we have to use the molecular weight or molar mass. This exercise we did in earlier video. Now, let us, with that plan, let us start this question. Start with 14 gram of, right? 14 gram of, I have C2H4, right? So, I need to get the moles. So what I do is I put moles of C2H4 on the numerator. I put grams of C2H4 on the denominator. Okay, now what will be the number is, we have learned that 1 mole of any compound will weigh its molar mass, right? If we keep 1 mole of C2H4 on a balance and look for the display on the grams, it will give the molar mass. And the question has given us the molar mass of C2H4 is 28.1. I grab this number from your question. Now, I have to go further ahead because I have got the moles of C2H4. The question is asking for C2H60, right? So I have to cancel this C2H4. So I will write mole of C2H4 on the bottom, mole of C2H60 alcohol on the top. What is the ratio? I have to look on the equation. In this equation, it is simply 1:1. Okay, so I plug in 1:1. Now, I have to convert the moles into grams. I have to place moles of my alcohol C2H60 on the bottom, grams of the same compound C2H60 on the top. Okay, again, by definition, 1 mole of alcohol C2H60 will have its mass equal to molecular weight or molar mass. And the question has given us that number. We do not have to calculate by ourselves. It is given to us. Okay, so now you can see here. Okay, now you can see here we are given, right? We are given grams. From grams we convert into moles. From moles of reactant we convert into moles of product. From moles of product we got the grams of product. Okay, so these are the different steps we took in. Now to cross check whether you correctly put them together, whether you have set up correctly or not, you can go and check. The grams of C2H4, grams of C2H4 cancel out. The moles of C2H4, the moles of C2H4 cancel out. The mole of C2H60, the mole of C2H60, all these cancel out. We are left with grams of C2H60 on the top, right? So in your calculator, what you have to do is you have to take 14 times 1 times 46.1, divide that by 28.1, others are 1. So this is the grams you will get. And in the calculator, you will get something like, what is the number? Let me see in the calculator. Okay, you will get something like 22.97 gram. Okay, now you have to report this number in the correct significant figures, right? If you look on the starting number, you have 14 gram. This is 2 sig fig, right? Everyone got that? This is 2 sig fig, means now your final answer should also be reported in 2 sig fig. So to make this number 2 sig fig, you can write 23 gram. Because 9 is greater than 5, when you want to drop that number, you have to add 1 to the preceding one, so it becomes 23 gram. So 23 grams is the final answer for this question. Okay, so with this question, we pretty much exercise very important concept of the roadmap, and I will show you that in our next slide. Okay, so what we did, so this slide tells you the logic behind what we just did. Okay, we started with grams of A, means one of the reactant, that was given. We used the mole ratio, we used the molar mass and got the moles of that A, right? Once we got the moles of A, the question was asking about B, so we had to bring the moles of B in the picture. Now, these two ratios we get from the balanced equation, right? We use the coefficient to show the relation between them. Once we have the moles of B, now again use the molar mass to convert into grams, right? Every time you have a gram, you need to convert into mole, or you have a mole and you need to convert into gram. Always use molar mass. Okay, depending on which is on the top, which is on the bottom, you have to play around that, but it is the molar mass that helps you interconvert them. Similarly, if you need to convert from mole of one guy, let's say mole of A, and then you have to find the mole of B, okay, you have to get that, then you have to look on the balanced equation for that. Okay, so this is the formula, the mantra that we use in solving this kind of problems. Okay, and you will see later on in the question, you may be able to go from reactant to another reactant, you may go from reactant to product, you may go from product to reactant, right? Depending on what is given, what is asked. So it's gonna be fun. So let's continue. Now, we are going to use these kind of questions to solve the % yield of experiment. To understand that, let me say that whenever in the lab you do some kind of experiment, okay, we always try to know at last how much was the % yield. Right? So the % yield actually giving us the information about how much the ratio of the actual yield that was formed out of what was possibly you could make. Okay, when that ratio we multiply by 100%, we get % yield. So it means that how much you actually end up making out of how much you were expected to make. Okay, so this is funny because in the lab, okay, no matter how much we try hard, how much we were careful to do our experiment, always the actual yield or the actual mass, yield means mass, the actual mass of the product will be less than what it was expected to. Okay, because there might be side reactions, right? Maybe the starting material that you are doing the experiment is not pure enough, right? In that case, the product that you are looking for may not be 100% all the product, right? It might have side products. The impurities might bring you something other masses in them, right? So always the actual yield will be lesser than theoretical yield. Only if you forgot to dry up your product and it is wet and in water is contained there, then the mass of water will be accounted for the product's mass. In that case, the percentage will be more than 100. Okay. Otherwise, the % yield of the experiment we do in the lab, every time it is less than 100%. Okay. So what is the actual yield? Actual yield means, as the name sound, it is the amount of product that actually formed after you do the lab experiment. Okay, so actual yield is the amount of mass, right? The mass of product that actually formed. Now, what is the theoretical yield? This theoretical yield is the actually when we get from doing math. When we theoretically consider that, oh, this much is the starting material's mass, then when the reaction occurs, this much product should be formed, right? We expect the amount of product when we say the reaction is complete, when we feel like all the limiting reagent is completely consumed, and we look on the balanced chemical equation and work with the stoichiometry, just how we work in earlier slide, and we get the mass of product, we call it theoretical yield. Okay, so what is the limiting reagent? We will see in a next slide. So when we use the math, the stoichiometry, the mole conversion to calculate the mass of product, that guy is theoretical yield. When we work in the lab and find out the mass, or the question might given you the actual yield, that is the one that goes on the numerator here. Okay, so let's see how does the question look like when we have to calculate the percent yield. If the reaction of ethylene with water to form ethanol has a theoretical calculated, okay, theoretical is always calculated one, okay, through the math, is 23 grams, okay, of ethanol, what is the percent yield if only 15 grams of ethanol are actually formed? We have to remember this expression, okay? Percent yield is equal to actual yield divided by theoretical yield times 100%. I see the spelling of yield is wrong here. You can correct it yourself, okay? So actual divided by theoretical times 100% gives you the percent yield. You look on the question directly gives you the theoretical yield and the actual yield. Place those number correctly. Actual is 15 gram here, theoretical is 23 gram here. Multiply that ratio by 100%, you get 65%. Okay, so we can do the question related with the percent yield when the actual and the theoretical yield are directly given in the question. We plug those in the definition of percent yield and solve for it. Okay, so in today's class, we learn how to use the number of moles, find the relation between the moles of reactant to product, and how to use that in a word problem, converting from grams of reactant to grams of product, and how to calculate the percent yield. We looked into these problems. These are very important problems of this chapter. Please review these problems, work by yourself, try more problems in the practice set. There might be more problems in the Connect homework as well as your quizzes. Okay, work on them and master this concept. In our next class, we will continue learning about the limiting reagent and more math problem. Okay, thank you.